Welcome back to my channel Bal Vigyan Bharti, and here is your mentor Abhilash Sarkar. We have already covered quadratic equation and we have solved few problems. And as I said, in quadratic equation there is no much variety of problem can be seen. Only thing is that the solving method that I have shown, you practice different means number of problems in at your home, so that you can be able to solve rather factorize the quadratic equation. That is the only toughest part or the procedure that you can solve the things. Once you will be able to understand the process, you will be able to solve the quadratic equation easily without doing much of the calculation. So that is the that is the beauty of that process. If you once get the confidence on that, it will be very easy for you to. So I'm not going to any further problem solving in quadratic equation. That is could be a monotonous thing for you to see or watch my videos. So I have dropped that. Meanwhile, somebody has requested me on some subjects. There are 2 3 subjects. The first one is some request has came to solve some problem on distance, speed and time. Probably I have covered the kinematics there. This parameters or these variables being taken care, and we have solved several problem after understanding the theories. So but as request has come that I will cover few. I am not going to that theory because theory part already I have covered. You can see it at my episodes where I have discussed kinematics, starting from the first episode, because there are some theories and followed by some numericals. But still I will solve some of the problems for the understanding or the advantage of the students. And few more subjects has came as a request that I have still not covered. So for those subjects I will first explain the theories and followed by the. So my next after this speed, distance and time problem solving session, I will come to those subjects directly. I will not pick my own subjects. I will cover those subjects. Okay. So that is my intention to cover. So I have explained it. So let me take problems on this time. I will cover time, distance and speed. So these are the terms which we have read in kinematics. Okay. So again I will just solve problems only. Okay, this time. So let me take the first problem. A person travels from one place to another, at 30 kilometer per hour, and returns at 120 kilometer per hour. If the total time taken is 5 hours then find the distance, then find the distance. Okay, so now this is very preliminary problem to solve. Now as you know that this he is traveling between uh, two points whose distance while going onward journey and returning are same. That means the distance is, we can think of same, d. A person travels from one place to another, means from place A to place B, I am assuming, is traveling. Onwards journey, the speed is 30 kilometer per hour, and while returning journey, the speed is how much? 120 kilometer per hour. Total time taken is 5 hours. So the total time of the journey is what? Is forward journey time plus return journey time. This is the addition of the time taken to move from A to B and the time added to the time taken to go from B to A. Initially forward journey A to B, then B to A. The total time is, let be the time taken for forward journey T1, this is T2. So total time T total is equal to T1 plus T2. This will be my initial equation. Now you know what is the time. The total time is said to be 5. Now if you put the value, but how about this? You know that time is nothing but for uniform velocity, because or speed, there is no variation in the speed, because he is moving with the person traveling in a car or whatever vehicle is using, is traveling in that with a constant speed. For constant speed, time is equal to what? Distance upon the speed itself. Now you know the distance is what? D. I am assuming the A to B, the length of the journey A to B is D. So this is D. D upon S1 is this kilometer, because everything in the same unit. So this is our total time in hour. So I am not bothering to convert the units. You have to look at it at that way. So here D can be assumed in kilometers. So everything will be matched, because speed is in kilometer per hour. Time taken for total time taken is in 5 hours. So I am not bothering to change the units. Remember that if there is a variety of units, so first and foremost function for you or role for you to convert and bring all those units in same unit. If it is length is in kilometer, time is in second, so every length or the speed has to be converted into kilometer per second. Remember that. So this is your first task when you will get some problem in your hand. Convert all the things in same unit. Though if you complete it at first point, then there will not be any chance of doing wrong. Okay, but don't try to do it in between the calculation. Do it at your first instance. Okay, so here, as because there is no change in the unit, I am not bothering to change the unit. So D is kilometer, I am assuming. S is 30, I will say straightforward right, 30 plus again D, because return journey also the same distance, B to A same. The speed this time is 120. So this is your total equation. Now solve it. The solving will be very easy. Once you are able to establish the equation, solving won't give you much trouble. So how will you solve that? So d and d, so d can be taken out. This is nothing but 1 by 30 by 1 by 20. 120 is equal to 5. So d is equal to 5 into, I am just going with the basics. Otherwise, if you want to put the formula, every time you will not able to remember the formula. Better do the thing stepwise. You need not to remember the formula. Otherwise, if you slip some of the part of the formula, you will be nowhere. So I am just going through the concept by the formula being established. Okay, so understand that it will be very easy. So this will be 30. I am not doing any LCM of that. I am simply putting the value as it is, 30 into 120. I am putting this LCM, so that will be 120 and this will be 30. So this will come below 30 plus 120, 150. So everything is coming on the right hand side except D. So I can find the D, because find the distance now you can calculate yourself. 30, 3, 5, 5, 5. So everything is, you can say, only 120. So 120. Now you need not to worry about the unit, because I am not changed. So whatever length unit you are getting, because this distance is nothing but a length unit, whatever length this unit is there in the question, that is in kilometer, your distance will be in the same unit. That means your distance is in kilometer. That will be easy to write the unit directly. Okay. Okay. Number 2. I am going slow. Okay. Just I am repeating every step and every moment again and again, so that who are new to this subject can also understand the problem. Okay. Traveling at 3/4 of the original speed a train is 10 minutes late. Find the usual time by the train to complete the journey, Okay. So again, it is also very simple. Traveling at 3/4 of the original speed, a train is 10 minutes late. Okay. Now, the question itself saying two conditions, means traveling at 3/4 of the original speed. That means the original speed, if we can assume something, original speed, let's say be S. So this is S. So the traveling speed is what? 3/4. This is the only simplest thing that you can assume, because traveling at 3/4 of the original speed, that means there must be something original speed, of which 3/4 is the real traveling speed. Okay, real traveling speed. So this is the thing, from the first line we can establish. The train is 10 minutes late. That means with S, the time, if it is T, with this speed the time is 10 T minus 10, and it is in minute, so I will assume this all are minute. I will not take any other. Okay, then unnecessary conversion will come. So whatever the numeric value is given, I will match the unit of the assumed value with the same unit. So this I will assume this to be minute. So then t minus t whole will be in minute. There is no ambiguity. As speed doesn't have any unit there, so I will not put any unit there. I will simply will calculate depending on the depending on the information, because time is only given there. So what is the requirement? Find the usual time by the time. So there is no need of this. So the speed can be assumed in any, means you can assume it kilometer per minute or meter per minute, because at the end that meter will be cancelled out, because I will get something of time. The time has only minute unit, so this definitely will not be there after I will solve the problem. So this will I am taking as meter per minute. You can choose as your own. There is no harm if you even take it as kilometer per minute. There is no harm in it. Centimeter per minute. There is no harm in it. Okay, nobody can say you wrong. Okay, but while you are taking such you are solving such problem, is traveling the speed and there is a train is involved, your unit must be very appropriate. Okay, if not somebody is asking your sense to be such that train cannot move in meter per minute, some meter, it must move kilometer per minute. Okay, with that assumption you can take, but it would not affect your calculation. Now find the usual time. How will you find? Now speed and time, respective speed and time is given. Now when something is being compared, you must keep it in mind, they has to be compared with the equal distance. Otherwise how will you compare? Whether he is taking more time or less time, there must be something which is a fixed distance. Find the usual time by the train to complete the journey. That means complete the journey means a definite journey. That means from one point to another, in between only I am calculating my journey timing. So there I can compare. So your distance must be same. The thing is similar. Now the time t for first case minus, now this I can assume t1, this I assume t2. Okay, now t1 means t2 is higher, 3/4 is the original speed, 10 minutes late, that means 10 minutes, sorry, I have taken, there has to be more time because this is a lesser speed, distance is same, distance is what, speed into time. If you keep this in mind, there will not be any problem, because as distance is same, when speed is more, time will be less. When speed is less, time will be more. So definitely it come as a plus sign. Now this is t1, this is t2. t2 minus t1 is equal to 10, that I know. T plus 10 minus t, it will be 10. Okay. Now how will you get t2? The distance upon the speed. Speed is 3/4 of s, we have assumed, minus d upon, what is that speed for it for the first case, d by s. t1 I am getting by moving the same distance with the speed, so speed s. For the second case, distance by 3/4 of the speed. Okay, now solving this, so let me take d out, so this will be 3/4 and 1 d by s I am taking common, 3/4 minus 1 into 10, so d by s is equal to 1/3, 3, so into 10. I am just not going to solve step by step, rather I'm skipping, because 3 by 4 by 3 minus 1 is equal to 1 by 3. 3 will go there, so this is 30. So d by s is equal to 30. Now find the usual time. So d by s is equal to 30, distance upon time. So what is this telling to you? This is the same thing. That means d by s is equal to 30 means this is telling t1. So what is usual time? Usual time for the first case where he is moving with the distance with s, getting t. So this is your usual time. So this is has to be calculated. Now this is equal to t1. So t1 is equal to everything. The time unit is given in minute. Suppose where it is. Yes, only the time unit is given in minute. So this is equal to 30 minutes. So that means usual time. That means usual time is the actual original speed. With the original speed, the distance covered in what time? T1. So this is your T1. So T1 is equal to 30 seconds, 30 minutes. So this is will be answer. Understood? Okay. Okay. Number 3. After traveling 50 kilometer, a train meets with an accident and travels at 3/4 of the usual speed and reaches 45 minutes late. Had the accident happened 10 kilometers further, on it would have reached 30 minutes late. Find the usual speed. Find the usual speed. Now see, this problem is just, the first part is just similar to the earlier problem, and there is an extension to find some more information. So what is that? After traveling 50 kilometer, a train meets with an accident. So this is the cause. After that moved 50 kilometer. Okay. So if I break this journey into 3 points, where your final start point and end point be A and B, and there is a point C where accident happened. So AC is your 50. Just see how I am just breaking this problem into fraction or parts. That will make the thing easy. So this is kilometer. Just calmly, very quietly read the problem. Don't be panic and the problem will be solved easily. After traveling 50 kilometer, at point C, train meets an accident. Here it has met an accident at and travels at 3/4 of the usual speed. That means he is moving with the speed s. Let's say now usual speed is s. Now further journey he is moving with the usual speed, means usual speed of 3/4 of the usual speed. That you can write, okay, and reaches 45 minutes late. So if he has had moved with the same usual speed as, he could have reached, let's say, time t. Now as he has met some accident here, the total time of travel become t plus 35 minutes and reaches 45, is taking 45 minutes more, isn't it? Total time, not that the partial time. What he is saying, let it be read again. After traveling 50 kilometer, a train meets with an accident and travels at 3/4 of the usual speed. Travels 3/4 of the usual speed is s. Travels 3/4 of the usual speed and reaches 45 minutes late. With whom? If the train could move with the usual speed until the end point, he could have taken t time. Now this case, after the accident, he has slowed down his speed and the total time is 45 minutes more, is reaching 45 minutes late. So this first information is quite clear. We have established everything here. Had the accident happened 10 kilometer further, so forget about this part. Now with the first information, time, so the time taken for the usual speed and the accident case would have a difference of 45. So t1 minus t2 minus t1, this is t2 higher minus t1 is 45. In the last case, what did we do? T2 minus t1 is equal to 45. This is my first equation. Now t2 I will get, because the t2 how will I get? 50 kilometer plus this is unknown. This is, let's say, b d, this part. After 50, the total distance is or else take ab, total distance be d. So this is 50. So 50 he is moving with the usual speed. So 50 the distance upon the speed time. For t2 how will I get? Total time. The time taken for this journey t1, this t2. So that t plus 45. That means t plus 45 I will get with by t1 plus t2. Or else I have to take this different, otherwise you will be confused. Let me take, I am not writing all this, otherwise the total time for first case is equal to capital T2 for this case where accident happened, and for usual case it is T1. This is a simple one. Now T2 consists of two parts, small t1, small t2. So T2 is equal to T1 plus T2. Okay, but my equation I am writing it here. Okay, for the first, T2 minus T1, the capital T2 is equal to 45. That has been declared here, 45 minutes late. Now capital T2 again consists of two timing, T1 plus T2 and minus the capital T1, that I am going to calculate now. Okay, now I am rubbing this part because I need this. Remember, this is for 50, this is 3/4 and all this parameter. Now I am writing it here. Now T1 the time to go 50 kilometer. So distance upon usual speed, because before the train met accident, he is moving with the train is moving with the usual speed, that 50 by s, plus after meeting the accident the remaining distance, because total distance I have taken t, so t d minus 50 will be the remaining distance. isn't it? Divided by speed, that would be the 3/4 of the usual. Fine, because distance upon time is equal to distance upon speed is equal to time. I am calculating t1, so this is your t1, small t1, this is your small t2, minus small capital T1. Capital T1, the case where no accident being happened. So we are assuming the train is moving with a usual speed. The usual speed is S, but distance is capital D upon the usual speed is S. So total thing has brought down here. So this is your capital T1. Just for understanding, I am writing this. This is not the power. This is the small t1 calculated by the distance 50 km by the usual speed. T2, the second part of the first journey. The remaining distance D, total distance D minus 50 already covered. The remaining distance after the accident with a small with a reduced speed, that is the 3/4 of the usual speed. That is okay. Minus, if the train not met any accident, that train will move the total distance D with the usual speed, that is equal to small s. Okay, understood? So this all is equal to 45. Now how many variable you can see here from here? You can see only variable D and S, but there is only one equation, so you cannot solve it. So better reduce this part. So I am rubbing this part because this is already done. Okay, why I am doing? Because the second part would be the part where I will get one more equation to solve this. So just let me reduce this part first. So 50 upon S plus D minus 50 by S, and this will be multiplied by 4 by 3 minus D by S equal to 45. Let me reduce it further. 50 upon S plus D by S minus 50. This will be multiplied by 4 by 3, 50 by S into 4 by 3, and minus D by S is equal to 45. Now 50 by S, this is 4 by 3, this is 4 by 3 DIS. So this will be 4 by 3 minus 1. So this will be 1 by 3 into D by S will be one side, minus, this will be similar, will be treated, but this is 1 minus. So minus I have taken common. So this will be 1/3 into 50 by S equal to 45. Now that can be 3 can be go and go this side. So D minus 50 upon S, this is equal to 45 into 3, that means equal to 135. So this may be the first equation you can say. So remember this, I will write by rubbing everything on the top. So only thing I need the final form of the equation. So D minus 50 is equal to 135S. This is my final equation. Okay, now we'll work on the second part. Had the accident happened 10 km further, so 10 km further means initially that was the 50 where the accident has happened. Now I will take this A and B will be the fixed points. Now accidents happened at some point. Let's say this is point E, and this AE is at a distance 50 plus how much? Happened 10 km further plus 10. The only difference will come, instead of 50 it will be 60. There is no variation in other cases. It would have reached 35 minutes late, and the late time is 35. Now the equation is same. T2 for the journey when accident has happened for second case. So I will take it how it is, T2 for dash I am taking, where the accident has happened 10 kilometer further. So I am distinguishing this with the T1. T1 will be same because there is nothing, the pure journey. With the usual speed the train is going. So T1 will be the same as T1 here. That difference is 35. In earlier case is 45 because the accident has happened 50 kilometer apart from the starting point. Now this is 60 kilometer apart. Only thing is changing here. So this also have some two part. First part is T1 dash plus T2 dash minus T1, that is equal to 35. Now see, T1 is what? The time taken before the accident for 60 kilometer. So 60 upon the usual speed, because before the accident the train will move with the usual speed. Second part, the distance is d minus 60 and the movement will be the same as 3/4, because after the accident it has assumed he has reduced the speed by 3/4 of the usual. So 3/4, not the reduced speed is 3/4. So reduced speed is 3/4 of usual. We can take the same condition of the first part, because there is no other information given. So you can assume that after the accident you only train can reduce to 3/4 of this. So this is okay. Minus T1 is total distance by total time, that is the same, is equal to 35. Now I will rub this part because I have already established the equation. Now we will put it in a form similar to this. So this will all together be, this will turn up. Now I can put 3s as LCM. Now S is equal to 180. I can put it here, plus this is already 4 will go up, so 4D, because 3s is already there, minus 240 and minus 3s means 3D is equal to 35. So this will be D minus 60 and this will go that side, 3 into 135 S. Now this is my second equation. Okay. This I made correct. 4 will go that side, 4D minus so what was the sum exactly? What is the need of that? The need was to find the usual speed. The second part, had the accident happened 10 kilometer further on, it reaches the 30 minutes late. 30 minutes was this, so this is okay. So now this is first equation, this is second equation, and both equation. Oh sorry, this is sorry. 35 into 3, that means it is 105. That's why I'm thinking why that equation is coming same. Now it's okay. Now this is equation 2. Okay, so what I have to find? Okay, you have to find the final speed, usual speed. That means I don't need D, so I can replace D from here. So from D, if I replace from the, what I will get, D is equal to 135 S plus 50 from the equation first, and put it here. So this is 135 S plus 50 minus 60 equal to 105 S. in second equation I'm putting. So ultimately 130, this will become this side, so that will be 30s, and this will be 10 on the other side. So your S is equal to 1/3. So what is the S is the usual speed. Now a unit is given as kilometer and minute. So without calculating, if I write kilometer per minute, that also be right answer. Or if not, any option is being given in particular unit, so you can solve it. Otherwise, if you can this is 1/3 of a kilometer, means 0.333. Or if you have to calculate in meter per second, let me assume that option is given in meter per second, then you have to do accordingly. So kilometer to meter, this it will be multiplied by 1,000, and minute to second I have to multiply. So this will turn it into meter per second. So that way you can solve it. So this is nothing but 100/18. This could also be the answer if it is options is given in particular unit. So accordingly we have to convert this into that unit. Otherwise, if you keep it as an answer, final answer, there is no harm in it. Okay, fine. So I will stop here because I am taking time. So video is going lengthy. So I will solve slowly few more problems so that it will be helpful for you to understand the way of solving. These are very much easy problem. If you don't panic, it can be solved easily. Okay. So thank you for now. Bye.